Alright, welcome to the video for learning target number 4 and 5. We're going to do both in the same video, okay? We'll quickly read those learning targets. I personally think that these are the easiest to, actually, all the rest of these I think are easy. I felt like these two are the hardest, personally. Now, some of you thought those were easy, so good for you guys. That's awesome. So we're just going to concentrate on learning target 4 and 5. So I can understand and describe the difference between surface area and volume. So you got to tell me, if I ask you, what is volume? You got to be able to tell me what it is. If I ask you, what is surface area? You have to be able to define that, okay? I expect you to be able to define these two things. You may want to, rectangle those in and just put define, okay? Because I need to know that you guys can do that, okay? Also, I can determine what measure, whether it's surface area or volume, matches the context for a problem situation. That'll make sense here in a minute. And also, learning target 5, we are going to be calculating the volume of rectangular prisms. And you can obviously see then the next video after this one will then be surface area and then real world, and then we're done. So this is only got like two more videos. It's going to go really quick. Okay? All right, so let's flip in your notes to, let me find the right page. You'll appreciate all the crazy language that's going on in there. I don't know what that is. Oh, there's our learning target. It's awesome. Okay, so volume. Okay? Volume is, we got to understand this, and I want you guys to all draw this. Okay? And here's how you draw it. You draw a square. Okay? And then you're going to put two diagonals like this. And then like this. And then you want to make this back one like parallel to this one if best you can. There you go. And then you want to make this right here parallel to this. So I'm a little off, but close enough. And then you should put some dotted lines behind here connecting that back side. Okay, that's how you draw a rectangular prism. Okay, now specifically I want you to know that when we're talking about volume, we're talking about a 1 by 1 by 1 cube. So we're going to write that 1 by 1 by 1 cube. Okay, that's very important that you know this. Okay, you'll think back to area when we did area in the we knew that if we had a rectangular rectangular hallway, we knew that finding the area, yeah, you would do base times height, so 10 times 4. This has an area of 40 feet squared or whatever the units are, okay? But what that meant is there are 40 1 foot by 1 foot squares that would cover it. So there would be 40 of those that would cover this entire rectangle. Well, volume is very similar to that. And the only difference is we're talking about a cube instead of a square. Okay, so we're saying how many of those will fit into an object. So the blank of a 3D figure like a cube. Okay, so would say the inside. I really don't love these definitions, but we're on here. It's just the inside. So we're trying to ask how much space does this entire thing take up? Or you could say how many 1 by 1 by 1 cubes would fit in there. Now, since that is 1 cube, and you couldn't fit more cubes in there that are 1 foot by 1 foot by 1 foot, this has a volume of 1 foot cubed. And that's what it means. Okay, it's always measured in units, whether it's centimeters, meters, and instead of a little square, we do a cubed. Okay, and the whole idea is, again, because we're talking about how many dimensions when we're talking about a prism or a 3D figure. We're talking about a base or a height, a base, and a height, or a length. There's 3 different lengths, 3 different dimensions. Okay, whereas area, we were only talking about 1 dimension by a second dimension. Those are 2D. Okay, represents the amount of space of a 3D figure. How much space something takes up. Okay? All right, go to the next page. Okay, here, this is a cube because it says it's a cube, so I know that all the lengths are the same. This, and this are all the same length. Okay? The volume represents what can fit inside. Exactly. It's how much can fit in there. Whether we're talking about water, whether we're talking about pop, whether we're talking about whatever, anything you're trying to fit something in something, we're talking about a volume. Okay? Whereas surface area, on the other hand, that is going to be the area. I'm just going to take that definition. I don't like that one. always measured in its area, so we're going to say, just like we did from last chapter, units squared. This is no different. This is just area, but the difference is we're not just finding the area of a two-dimensional figure. We're now finding the area of the three-dimensional figure. You guys see that? We're finding the area of each surface, the front, the sides, the top, the left side over here, the back, the bottom, and then you add all those areas up. Okay? It is the sum of the area of take out all, take out of. It is the sum of the area of each face of a 3D figure. As I just said, we find the area of the front, we find the area of the back, we add them together. We find the area of the right side, left side, add it all together. Okay? And it represents the outside covering. Say it like that. Outside covering of the figure. Okay? This right here, example for the cube above, so we're referring back to this. If I wanted to find the surface area of that, that could tell me how much area of wrapping paper that I need, because again, that wrapping paper just covers. Remember, area always will just cover something. Okay? 1 second. My board is freezing up here. Okay. All right, so now we got to go down. This was learning target 4 right here. All of this is learning target number 4. So it's just being able to determine whether we're talking about volume or whether we're talking about surface area. The amount of milk in your glass, well, pretty basic here. I think you guys realize that that would be volume, okay? Because, you know, volume is how much will fit into some. Just remember that. How much will something hold? That would be volume, okay? The amount of wrapping paper you need for a present, well, we just talked about that. That would be surface area, and I'm fine with you just putting V and SA. The number of pencils that can fit in a container, definitely volume. Again, we're trying to fit something in something. Okay? The number of gallons of gas in your car, volume. Absolutely. You're saying a liquid. How much of a liquid can fit into if this were my gas tank right here, how many gallons of gas would fit in there? What an amazing gas tank, by the way. The amount of paint you need to paint the outside of a mailbox. Now you're just painting the outside of the mailbox, therefore this would be surface area. Okay? Because you're just painting the surfaces. That makes sense, guys? If I asked you how much paint was in this can right here, that would be a volume because I'm asking how much paint is in there. But this one, I'm just painting the outside of a mailbox, the surfaces. Okay, the amount of orange juice that will fit into a bottle, definitely volume. Try the last two on your own real quick and then play the video. Okay, the number of gallons of water that are needed to fill your fish tank, well, that's clearly going to be volume, okay, because you're filling something. The amount of toilet paper that fits around the roll, just enough to cover it. So it doesn't mean all of it. It just means just the amount that would actually cover the cylinder one time. That would be surface area. Okay? Anytime you're just fitting something around something, or you're just wrapping something, or you're covering something, those are some key words for surface area. Whenever you're doing volume, you know the words will be like fill, how much would fit in it, something like that. Okay? Let's go to the next page. Alrighty. Now we're going to get, oh, there's more. Good. Okay, so we can do some more here. How much of your interior of your swimming pool will be covered by 1 can of paint? Notice it says the interior of your swimming pool. So we are just painting the actual sides of your swimming pool. That would be surface area. Okay, the amount of water needed to fill, bang, we know that's volume. How many boxes can fit in a storage room? Clearly volume. We are seeing how much could something fit in something. How much water is needed to fill each section of an ice cube tray? Definitely volume. Okay, the size of a label on a soup can? Definitely surface area, because we are just covering that soup can. Okay, how many noodles can fit into a soup can? Be volume. Make up one on your own. I want you guys to all try one. Make one up on your own. Make up one for volume, a real life volume, and make one up for surface area. And we'll talk about that tomorrow. Please remind me to talk about those too. Okay? All right. Learning target number 5 now. We are now finding volume. I know you can't read mine, but it's supposed to say learning target number 5. I can calculate the volume of rectangular prisms. Now, this is where it's going to get a little bit different, guys. Okay, this is where, you know, you got it. I know Mr. Glassburn, and he's not wrong, taught you this formula right here. That's the formula he taught you, and he's not wrong for doing that. Okay? But this formula will only work if it's a rectangular prism. This will not work for a triangular prism. This will not work for a trapezoidal prism. This will not work for a horizontal prism. This will not work for a hexagonal prism. This will not work for any other prism other than a rectangular prism. Okay? So I want you all just to forget about that formula. Okay? We are going to learn a brand new formula. Okay? So this is our formula. I need everybody to write it really big. And we're going to write it several times. It's V equals, volume equals. Now pay very close attention how I want this done. You have to use a capital B times H. Okay? This is not base times height. Remember when we did area last chapter, we wrote it like this, and I always used a lowercase b. Okay, this is strictly just saying I have a rectangle, there's my rectangle, this is my base, this is my height. Capital B does not mean base length. What capital B means, and make sure you're writing all this, this is the area of the base shape. Okay? Make sure you're getting that. So we're doing the area of the base shape times the height. Okay? Actually, let me erase that. I want to then tell you what the height is. The height is the distance between the bases. Make sure you get that down. Okay, let me explain that one more time. Big B, capital B. I will expect you to show it like this. If you show a lowercase b, it will be incorrect. It is capital B times height. But it doesn't mean base times height. That's what I'm trying to get you guys away from. Okay, that base times height is area. Volume is area of the base shape times the distance between the two bases. Now let's recap real quick. Here I have a rectangular prism. We know that this has 6 sides. Okay? Remember, the base shape is the one that's being stretched. So let's say we called the front here the base shape. Okay? That's the base shape. If you called it that, then the other base shape would be the one in the back because it's being stretched from front to back. Did you guys see that? But you don't have to call that your base shape in a rectangular prism. Okay? For instance, this right side right here, you could call that the base shape along with the left side. You could call the top the base shape along with the bottom because it's being stretched from top to bottom. It's being stretched left side to right side or front to back. Does not matter. Okay? So, we have to find the area of the base shape. So basically, you know that it's kind of this, actually. And I want you to write this too. It's really, if you write this formula, it's really saying, okay. And I hope this doesn't confuse you, but it's basically this. Area of the base is base times height. Okay, that's the area formula because you know this is a rectangular prism. So that's the formula for a rectangle. So it's the area of the base times the distance between the bases. Okay, and that's, remember how I told you when we did trapezoids and I told you I don't want you to say 1/2 height times base 1 plus base 2? How I don't want you to say it like that? I expected you to say it as, the formula for a trapezoid is 1/2 times the height times the sum of the bases. That's kind of how I want you to explain it. This is exactly how I want you to explain volume. I want you to explain it as, it is the area of the base shape times the distance between the bases. Okay? So let's take a look at this one. This is all, I love the way this is done right here. They went ahead and they called the bottom the base, which is fine. Doesn't matter. They went ahead and called the bottom the base. Okay? They found the area of the bottom. Do you guys see that? Now they went ahead and put little squares in there because that's truly showing area, 1 by 1 squares. Okay? So what they did is they said, okay, the area of the base shape, so in other words, the big B equals 8, and they should have had units squared on here. Okay? Because that's just area. And then basically you're saying, okay, if this is my base, how far was it stretched? And there's where our height comes in. How far was your base shape stretched? Okay, and that's the whole point. Which is why, when we do the formula, we would do it like this. This is what I would expect to see. Big B times H. Okay, I know that the area of the base is 8. Okay, because it's a rectangle, 4 times 2. And I'm getting all these dimensions from this up here, right? My base, right there, 4 times 2. Okay, and then I multiply by the height, which is the distance between the top and the bottom. It's going to be 8 times 3. We're going to get 24. And then, of course, we need to have units cubed. Okay. Now, what does that mean? That means that it would be, not the best drawing, if I asked you what does that mean, I expect you to say that this box right here, whatever it is, this rectangular prism, it would have 24 1 foot or 1 unit by 1 unit by 1 unit cubes that would fill it. So I would need 24 of those to fill it. And if you go back and count them, it makes perfect sense. Okay, we have 1, 2, 3, 4, 5, 6. There's 6. Okay. 1, 2, 3. 1, 2, 3. 1, 2, 3. So right now let's count up 3, 6, 9. And then I'm not counting these because I already counted them here. So 3, 6, 9, 12, 15. But then remember, we got to count the ones on the back. Right? And I guess the better way to probably have done it than what I just did, I might have just confused you. I hope not. But it's easier just to count fronts. So I have 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So I have 12 cubes in this row from right here over. You guys see it? That'd be 12 of them. And then how many do I have on the back side? I have also 12. 12 plus 12 is 24. Okay, let's go to the next page. What in the world? Oh boy. So here, I already broke this down for you. We wrote it on the previous page, but you can see that's what it means. Capital B means area of the base shape, and then your height is your distance between the bases, just like it was for a trapezoid. Remember that? Remember when we had a trapezoid, your bases were always the parallel sides, and your height was always the distance between those two bases. So that's kind of an easy way to remember it. Okay? Let's go to the next page. Okay, again, don't mind all the writing here. I'm going to, first of all, remember, this will be worth 3 points on the test. All of these will be. So we'll do them real quick. We write volume equals area of the base times the distance between the bases. Okay? And it's all up to you. What do you want to call the base shape? Now, for some of you, you might struggle with being able to know what the side lengths are on here. And here's my advice to you. Get highlighters if you have them. And I want you to just go through and mark all the sides that would be the same length. Those 3 would be the same, right? I know that this would be the same as this, which would be the same as this. And I know that this would be the same as this, which would be the same as this. That just helps me. The other way you can do it that a lot of students do it is they'll go through here and put 3 on there, 3 on there. We already know that's 2. We know that's 2. We know that's 2. Then we know that this is 6 and this is 6. And that'll just help you see it. Now, it all depends what you want to call the base shape here. If you want to call the base shape the front, then you would do this times this to find your area. Okay, that's fine. If you want to call the base shape the front, remember, a rectangular prism does not matter what your base shape is. If you wanted to say, okay, my base shape is this right side, okay, so you find the area of the right side, and then you're going to multiply by the distance between the right and the left side. If you thought the bottom of it, or the top, was the base shape, you find the area of the top, and then you say, okay, how far is it? How much is it being stretched to the bottom? Do you understand how top and bottom always to go together? Do you understand how front and back always go together, and right side and left side always go together? In a rectangular prism only. Okay, you'll see that this is different. So, or this is different for a triangular prism or any other prism. Okay, but this is the formula we always use. Okay, so I know I'm going to go ahead and use my front as my base. So I know this is going to be 3 times 6, and I like to put it in parentheses just so that I remember I'm going to do that first. And then, so that I'm calling that my base, my front. So now, how far is the front from the back? It is 2. And then from here, it's pretty easy. It's going to be 18 times 2, which is going to end up giving me 36. And then, of course, it's centimeters cubed. So let's go through the 3 points here, guys. 1 point right there. Formula, just like last chapter. Second point, answer. Third point, centimeters cubed. Remember, I always like to remember it this way. When I'm doing volume, I know how many numbers did I use total. If I use 3 total, then it's 3. Whereas when I'm finding area, 4 and 5, I'm just using 2, which is 2 numbers, which is why it's centimeters squared. Let's do another. Okay. this one here, 3 points again. Okay, so it's volume equals big B, capital B, which is area of the base, times the distance between the bases. Now, let's switch it up a little bit. Rather than use the front as my base shape, let's use the side here as my base. Okay, so again, if you need to go through there and write on there what all these distances are, okay, I know that that's 10, so that means this must be 10. This must be 10. I know that this is 6, so that means this is 6, and this is 6. And I know that that's 5, so that must be 5, and that must be 5. If that's something you need to do, do it, because it'll help you to see what each of those side lengths are. Okay? So the first thing I've got to do is I'm going to call my right side my base shape, which means my H here is going to be how far is it being stretched to the left side. Okay, so I know, again, I like to put it in parentheses. Okay, my right side, how to find the volume or the area of that right side is I'm going to do base times height. So it's going to be 10 times, I think that's a 6. I'm going to say that's a 5. I hope your copy, if yours said 6, then just make it 5. Okay, I can't really tell on mine what it is. Okay, so it's 10 times 5. That's the area of my base. That's big B, area of base. Now, how far is that right side being stretched across here? It's being stretched 6 centimeters. Okay, so now we do the math, 50, and then 50 times 6 is going to be 300. And then, of course, centimeters squared. That makes sense. Oh, I'm sorry, centimeters cubed, my bad. See, it's easy to make that mistake. So again, 3 points, 1, 2, and then centimeters cubed. By the way, when you're writing units on here, take note of this, everybody, because some of you don't do this right. Some of you come up here and do this and put the centimeters into cubed really small up here. It doesn't work that way. When you're writing this, the centimeter just get written right like a lowercase letter, just like you would any other time. The little 3 becomes the number above, like an exponent. Okay? Why don't you guys go ahead and try this one right here. Go ahead and try it. Pause and try. All 3 points got to be there, though. Okay? So again, length times width times height technically works, and you can see why real quick. I mean, you can see in our work right here why it works. I mean, aren't we just doing length times width times height there? I mean, that's what we're doing. But again, if I gave you a triangular prism, which I'm going to do here in a minute, it wouldn't work. You wouldn't be able to do length times width times height. So I'm trying to save you work and just teach you one formula rather than several. Okay? So again, we write the formula, area of the base times the height. What do we want to call the base shape this time? Maybe you did it differently. You'll get the same exact answer. I'm going to call the top my base shape. Okay? Okay, so I'm going to say area of my base is going to be, okay, that by that. What would that be? That would be 14 by, and then what's this distance right here? It's going to be 6, right? So it's going to be 14 times 6, again in parentheses. Now, if you did the front as your base, then you would have done 14 by 8. 14 times 8 is your area of your base. If you did the right side, you would have done 6 times 8 in parentheses. Okay? So since I did the top, now I'm going to say, okay, my area of my base is 14 times 6, so then what's the distance between my top and my bottom? It's 8. Okay? So I do that, and I'll have to get up my calculator to do it. So it's 14 times, oh boy, 14 times 6, 14 times 6, okay, which is 84, and then times 8, it's going to give me 672. So I end up getting 672 centimeters cubed. So it doesn't matter when you're doing a rectangular prism what you do, which one you call the base. Whereas in a triangular prism, there's a specific base. So your 3 points again, there, there, and there. Okay? Okay, I want to do one that's not on here really quickly. Okay? You don't have to draw this. You can just watch real quick. That would be fine. Okay? Alrighty. So let's say I put a triangle on here. Let me draw it real quick. If you want to try to draw it, you may. Do your best. That's fine. I just like to do it like this and make two congruent triangles. Those are close enough. And then now I'm just going to connect all the vertices. So there it is. Bang, bang. And then this should be a dotted line. You always want to make the ones behind a dotted line. Alright, so there's my triangular prism. Okay, there it is. It's all good. Now let me put some dimensions on here. Let's say this is 5 meters. let's say I have a height here of 3 meters. Okay, and let's say that this distance right here is 10 meters. Okay, now check this out. I'm just going to tell you right now, this formula right here, again, that Mr. Glassburn taught you, not that he's wrong for doing this, but this formula would not work here. My formula will. Okay, so let's do it. Volume equals big B times H. Now, here's the difference. We got to know what the base shape is. Remember, with rectangular prisms, it didn't matter what you called the base shape, whether you said the top, the right, the left, the back, the front, the bottom. It doesn't matter because every side is a rectangle being stretched. So that's what's kind of neat about rectangular prisms. Whereas this shape right here, this triangular prism, it only has one base shape. And the base shape is a triangle, right? Because that's what's being stretched. You don't have options. You have this, that's it. So again, my formula is big B means the area of the base. So here, I'm going to have to do 1/2 times base times height times height. Okay? Now that might be a little bit confusing. Again, big B means area of the base. So my base shape is not a rectangle anymore. Okay? If it were a rectangle, I would just do base times height like we did here. It's not. We got to do the area formula of a triangle then. Okay, so we got to find the area of the base here, and I'm sorry this video is running a little bit longer than I like it to, but this is important. So it's going to be 1/2 times 5 times 3. That's my area of my base. Now, what's the distance between the two base shape, which are the triangles? Be 10. See how I did that? See how my formula always works? Okay, and you're going to end up getting 40 meters cubed. This is why it's important to learn, this is why it's imperative that you all learn my formula. Because mine works no matter what the prism is. And I could draw a hexagon and make it a prism, and I guarantee you I could find the formula find the volume with that formula. So that's why it's important. You guys got to use this formula. And I will expect, if you put this, I will count it wrong on the test. Okay? So just know that right now, I will not accept it. Okay, so again, I found the area of the base, which is a triangle, base times height times 1/2, right? Notice it's meeting at a right angle there. And then the height, the H in the volume formula is always the distance between the two bases. Or in other words, how far your base shape is being stretched. All right? Okay, guys, again, sorry this ran a little bit longer than I wanted it to. The next one, we only got one more video of this chapter, and it won't be this long. All right, see you guys.